determination of sample size, and a review of statistical theory. This chapter's got a lot packed into it. For the mathematical among you, this will be a lot more fun. Others, it's going to read pretty dry, but you should be aware of the terminology, if nothing else. We're sticking to simple statistics and things of that nature, not multivariate things. But it is good to understand this so you can use the tools and get what you need. So basic terminology: frequency distributions, populations, central limit theorem, and so on. So descriptive statistics, we're going to describe populations or samples. What's the age breakdown of our customer population? Okay, that'd be descriptive. Inferential: what can we infer about the whole population from a sample? You don't need to talk to everybody in the group or in the population. We just need enough to make a judgment or an inference. So sample statistics: variables in a sample or measurements computed from a population parameters, different characteristics. So marketing data, or making data usable. Frequency distribution. Think bell curve. If you don't know what a bell curve is, look it up, read it. You should understand that, and the standard deviations. The bigger the sample size, the more typically a given sample will look like a bell curve or a normal distribution. And it's to show you different subsets or standard deviations from the norm, which is a central tendency. But percentage distribution, probability, relative frequency. To think probability, think frequency. How often would it occur? So here's frequency of distribution for deposits. There you go. Equals 100. A total population always equals 100. Again, probability that you can have under $3,000 in this account is 0.16, or it is expressed as a percentage, but calculated as a decimal. Well, it shows an average. Here's what we want to be careful about. Average, there's 3 different kinds of averages, all right, which are mean, median, mode. Arithmetic mean is what you're used to when you think of average. When somebody says average, they mean mean. It's better to say, so central tendency, the mean. Now, if we have a normal distribution or a bell curve, all 3 of these will be the same, and it won't be skewed one way or another. But sometimes you want to calculate all of them, is what I'm trying to say. So median, midpoint score, as many values fall above as below. It's the middle score, or the middle response. Again, as many different ones above as below. And then mode, which value occurs most often, mode. So that's why this is important. Again, all 3 of these might be the same if it's a normal distribution. So measurements, the range, smallest to the largest in the frequency. Here's low dispersion versus high dispersion. So it's clustered. The one on the left would be more grouped around the center, so that mean or average would be more reliable versus a high dispersion. So measures, variance from variability of the dispersion. These are things you want to calculate in order to understand the numbers and how accurate might not be the right word, but how narrow they are. So standard deviations. So here's what the numbers, how they run. That funny looking E is a summation. N is the number of an N of 1 means you talk to 1 person in the survey. N of 50, it means you've talked to 50 people in a survey. Calculating standard deviation, there you go. So normal distribution, IQ scores, normal, plus or minus 3 standard deviations, 90%. So 99% of values will fall in that standard normal distribution. In other words, here's symmetrical. Then if I has normal curve's highest point, normal curve has an infinite number of cases. It is a continuous distribution. And it looks like this. And you can see, so one's around the mean, or median or mode is 100. So a standard deviation up or down is you're going to grab 68% plus of the population is going to be represented by one standard deviation, and so on. So when you get to the outliers, those tails at the end, those are rarely occurring, or 2% of the population is going to fit into this could be a grade scale. And if you want to force fit a grade scale into this, you certainly could. A's, B's, C's, D's, and F's, and force everybody into that curve. Don't worry, I'm not doing that. There's a normal distribution, standard normalized, mean, median, mode are the same. Skewed or flattened, the different kinds of distributions. Different spread. So shaded area, standardized. And here's where, when we talk about data is skewed, it is pulled one way or the other from a distribution. So you see here, the X, the line over it, mean, standard deviation, values, and so mean, median, mode is going to be different for these skewed examples, like here. So again, you want to be careful about which one. You want to use all three in order to get the best representative sample. There's a good example how those populations spread out over time. Central limit theorem, as the sample size increases, n becomes a normal distribution because you're more and more in the population, and it's going to fill it out, and it's going to take that shape, sort of like that. Confidence intervals, specified range, numbers within a population mean is expected to lie, an estimate of the population mean, again, mean, median, mode, based on the knowledge that it will equal the sample population minus, plus or minus a small sampling error, because there's always an error. And then it just goes through more factors involved in terminology. Again, we're sticking to the simple stuff, but it's good to review this to kind of sharpen your skills if you do this on your own at some point in time. All of these are built into Excel, by the way. And if you want to know more, if you can go to the internet and go to Khan Academy, they've got all these, the mathematical way to do these things, the statistical processes. That should get you going.